Hey guys, it's me, Dr. Wisby, and I wanted to start talking about Chapter 21 today, Coulomb's Law. And I wanted to talk to you about the experiments I did on TikTok. We need to establish what the atom is. There are many different types of particles, and some things are electrically neutral, and some things are electrically charged. Inside of an atom, right? And the word atom is a Greek for the smallest particle, because the Greeks reasoned that if they had, say, a piece of chalk, right, and they broke it in half, right, well, eventually they could keep breaking their piece of chalk into smaller and smaller pieces, and until they got to a place where you couldn't break the chalk anymore. So maybe that is, I don't know, chalk dust. So if I took a piece of chalk and hit it with a hammer, eventually you just end up with a bunch of chalk dust. Well, the Greeks realized that at some point there must be a limit to how many times you can divide an object. And that's where they came up with the idea of an atom. An atom was a thing that you couldn't divide any farther. More recently, people started realizing that everything that we see is made up of atoms. These are tiny little particles. You probably know about it. And the atoms are made up of protons and electrons. And maybe you were taught that the electrons circle the protons like this. Maybe you could think of them like little planets or something like that. Nice little happy planets orbiting the proton there. Actually, though, if here's our proton, the electron is actually doing. Here's our electron. The electron's actually doing something more like this. That's really. Oh, jeez. Oh, well, sometimes it happens. They just tunnel out of the atom. Oh, look at that. I don't know, it's going in another dimension. This is actually what the electron actually is looking like. So, so inside of the atom, we've got these things, protons and electrons. Now, protons are actually made up of other particles too. So there are up quarks and down quarks. Inside of the atom, we've got other particles called leptons that compose the atom. And a proton has two up quarks and a down quark. Okay? Now, up quarks have a charge of plus two-thirds E. That means it's a fractional charge, and it has the same charge as an electron, 1E, and it also has a down quark. A down quark is negative 1/3 E. So we've got two up quarks plus a down quark. Right, so we have U plus a down quark. So that's 2/3 E plus 2/3 E minus 1/3 E. This is our down quark right there. Okay, so if we add all those up, all right, then we get 4/3 E minus 1/3 E. So that gives us 3/3E or 1E. So this means that the charge of our proton is positive 1. And this is in contrast to the electron, where one electron has a charge of -1 or -1e or minus E. Okay? And E is the most fundamental unit of charge. Now, an electron is also a lepton. Okay? Now, in an atom, the simplest atom would be hydrogen, and that is one proton and one electron. Okay? And they are stuck together. This has a minus charge, and the proton has a positive charge. All right. So if we remove one of the electrons, this atom becomes positively charged. But let's talk about the electrons. It's possible to remove an electron from an atom. There are many different ways that you can do this. But if you do, and you can add some of the electrons to, or remove some of the electrons from these balls, which are made of styrofoam, they will actually repel each other. And you see that there is a distance between them. And when I put my finger there, they are definitely attracted to my finger. And now the balls are not repelling each other. So the question is, what is causing this repulsion? Now they're right next to each other, nothing very special. But how could I make the balls repel each other? Well, one way I can do that is if I take a piece of glass and I take this silk cloth that has this hideous flower pattern on it that was handed down to me by probably from the 70s. And I rub these two together very quickly. So I'm going to really rub the glass rod very quickly. As I'm rubbing the silk onto the glass, something is happening to the electrons. Okay? So something is happening to the electrical charge of the silk rod. Okay? So now my silk rod doesn't look any different, but as I bring it closer to the glass balls, you start to see them move. So I'm not actually, and this one is attracted. And now, oh, okay, so both of these are very attracted. There we go. So these are very, very attracted to each other. Aren't we all attracted to bad things that we shouldn't be doing? Like, it's tempting to go out with your friends, but don't do it. Stay home, play video games. Hey, but as I get this nice and charged up, hey, if I'm very careful, you see that these things are at first attracted to it. Okay? And now one has. Now they are actually repulsive. And that's what I was going for. These two styrofoam balls are suspended. They're hanging down in my document cam, but they're suspended in space, and there's a force pushing them apart. Okay? So the question is that positive or negative? We know that electrons were being taken or given to this rod with a piece of silk, but we don't know what charge it is. Now, there's some force repelling these two styrofoam beads. As it turns out, with silk, when we rub it on glass, we're actually removing some of the electrons in the glass rod. This creates a deficit of electrons, and when I bring this over, that means that I can steal some electrons from the styrofoam rods. If I do that, then now my styrofoam balls are actually slightly positively charged. Since they've got this net positive charge, they experience a force on each other. So when you have two charges of the same sign, that's repulsive. Doesn't matter if it's negative or positive. If it's the same, they will repel each other. If you have positive and negative, then they're going to attract each other. Thanks for watching my video, and I'll see you in class tomorrow.
Thank you, like and subscribe down below.